In Chapter 10, we're going to talk about correlation and regression. So in 10.2, we start with correlation. Okay, so we say correlation exists between two variables when the values of one variable are somehow related or somehow associated with the values of the other value. The other variable. Okay, so we're saying they're somehow related or associated. There's some connection between them. Okay, so we're going to talk about what's called linear correlation. So do they correlate linearly? And there's two different things we can talk about, either positive correlation or negative correlation. So positive correlation means if we look at a scatter plot, the data points, the two variables, they would look like a positive sloped line. So from left to right, they would go up, okay, and they would about all fall in the same line. A negative correlation would mean that they would look like a line that has a negative slope. So from left to right, they would go down. Okay, and no correlation would be as if they were just all over the place. Okay, didn't look like a line at all. Now, we're going to find what's called the R value. And the R value measures the strength of the correlation. So we say the strength of the linear correlation between the X and Y values of the sample. Okay, we can find R on our calculator, so you'll put data into L1 and L2, and then here's the key sequence. You hit Stat, you arrow over to Calc, and then we choose number 4, Lin Reg, AX plus B. Now, sometimes you have to do a little funny thing on the calculator if the R is not showing up, and you only need to do this once. But if your R is not showing up, try this first. Hit second and then the 0 button. It'll bring up the catalog. And scroll down to where it says Diagnostic. It says Diagnostic on. And then you'll hit Enter. It'll take that to the home screen, and you'll hit Enter again. Okay, and it's just going to run a little program on the background, and then you'll get R value. So if it's not working the first time you try it, try doing that thing on your calculator. And you won't need to do that every time, just the first time. Okay, so R will always be between -1 and 1. Okay, just like hypothesis testing, we choose a significance value. And then to determine if there's correlation, we'll use table A6, which is in your formula sheet or from your book. So if R is negative, so we get a negative value, so between 0 and -1, there is negative correlation if we look at the absolute value of R. We don't look at the negative. If that's bigger than the critical value, we get off the chart. Okay, and if R is positive, so it's between 0 and 1, then we don't have to take the absolute value because it wouldn't do anything if it's bigger than the critical value from the chart. Then we get correlation. Okay, so one thing to know is that R values are very sensitive to outliers. So any outliers are really going to throw off your R value. And one other piece of information is that R squared, which you'll also see on your calculator, it describes the proportion of variation in Y that is explained by the linear relationship between x and y. So it's really just saying r squared tells us what percent of the change in y happens because y is related to x. Okay, so how much can we kind of base that change of y on x? Okay, and a really important reminder when we're talking about correlation and two things correlating is that correlation does not imply causation. Okay, so just because two things correlate doesn't mean either one of them has to cause the other. Okay, so we'll look at a problem here. So it says, as the circumference of tree trunks increase, so as they get wider, can we expect the trees to get taller? In other words, is there a significant linear correlation between the circumference of a tree's trunk and the tree's height? Okay, so we have 9 trees. They're all the same species, and we've got their circumference, and we've got their height. So their circumferences we put in L1, and their heights we'll put in L2. And if we want to make a scatter plot, okay, we're going to put their circumferences as the x value. And these are in feet. Okay, and then we have their heights as the y value, also in feet. Okay, and their circumference feet I'm going to mark off from 1 to 8. And their heights we're going to go from 10 feet to 70. Okay, so we look at the first one. It's 2.4 and 40.7, so it would be about there. The second one, 3.1 and 24.9. So we've talked about scatter plots before, so I'm going to pause this and finish the scatter plot. Okay, so here's our scatter plot, and we can see it does look like from left to right they're going up, kind of, not in a perfect line, but in a line. Okay, now, so after you put the circumferences in L1 and the heights in L2, and you did stat over to calc in the Lin-Reg AX plus B, our R value we get is 0.758. Okay, now you want to pull out this table A6, which again is in your course formula sheet or in your book. Okay, and you'll use that we had 9 trees, so you'll use alpha as 0.05 and you'll go down to 9, and we get that the critical value then is 0.666. So we compare our R, which is 0.758, to our critical value. And since R is bigger than our critical value, we can say that there is linear correlation between a tree's circumference and its height.